today is the 27th, and we're talking about quadratic roots. Alright, first things first. You need to know what a quadratic root is. So a quadratic root is the points at which the parabola, which remember is your quadratic equation, that's what it resembles, a parabola, intersects the x-axis. Now, the last time we talked about quadratic roots, we didn't actually talk about quadratic roots. We didn't call them roots. We called them x-intercepts. But we also said that they were called other names. And so some of those other names are, they're also called zeros. They're called solutions. You can have up to two real solutions. There is a such thing as imaginary solutions. Those work with imaginary numbers. We'll get to that in an upper level math class. Right now we're just working with real numbers. So, the first type of solution is 2. Oh, and like I said, they're called solutions because they're solutions to your problems. But if we have 2 solutions, this is what our graph looks like. There's our okay, and this is just one example. There's plenty of other examples too. But if you have a parabola and you can see that it intersects twice through the x-axis, it doesn't have to be intersecting perfectly here. It could be intersecting on the left, the right. It could be reflected over the x-axis and intersect. What matters is that it intersects twice through the x-axis. Then you have 2 solutions. So then if it's asking you for your answer is going to look something like x equals squiggly brackets your first root, which I'm going to call it R1, comma your second root R2. And that's what your solution will look like. Your answer, x equals squiggly brackets. You can't use parentheses because parentheses denote coordinate points. Brackets, so like the domain and the range intervals and things like that. So squiggly brackets are the way to go. Alright. Now, you can have up to 2, but you can also only have 1 solution. So a graph that had 1 solution, and remember this isn't just the only way a graph can look, this is just one example of the way a graph can look, is if we had this graph over here. Where you can see that, remember graphs are read from left to right. It starts approaching the x-axis, it touches it at the vertex, and then it turns right around. Because remember, the vertex is where the graph turns around. So this only has 1 solution because it only touches the x-axis once. Even though it doesn't cross it, it does touch it. And that means your vertex, number, comma, 0. So if your vertex comes out to be, you found your axis of symmetry and you're finding your y value for your axis of symmetry for your vertex, and your y value turns out to be 0, you're going to have only 1 solution, and that's going to be that vertex. And then if you need to graph it because you're more of a visual person, then go ahead, graph it, and you'll see that it only touches the x-axis once, so it turns around. And that kind of answer just looks x equals and just your root. And R stands for root. R1. Salem, take your tail somewhere else. cat likes to think he can lay on my stuff. Alright, and then the third type of solution that we'll be talking about is if you have no solution or zero solutions. Salem, stop. Alright, so one way the graph can look, remember they're not all going to look the same way, but one way it'll look is, it could look like this. This is just one way. And the thing with this one is you can see that it does not cross the x-axis. Your vertex comes close, goes towards the x-axis, but before it touches it, it turns around and says, nah, never mind, I don't want to do that. So there's two different ways you can write this kind of answer. You can write x equals and write your squiggly brackets with nothing inside of it. That's called the empty set. That means there's nothing there. And that's one way to write no solution. But the way that we've been writing it so far is a circle with a line through it, which also means no solution. So you can either write one or the other. Either one of the two works. But two solutions, you should have two numbers inside of your brackets. One solution, you should only have one number, and then no solution, empty bracket, or the no solution sign. But these are the three types of solutions we're going to have. Salem, I need you to move. Get your tail out of the way. Alright, so let's start with some examples. That is the word examples, because Salem seems to think he is the king of the world. So we're going to do one of each, just to kind of get the hang of it, and then we'll talk about the discriminant. So the first one is, take your paw somewhere else. Y equals x squared plus 4x minus 5. Alright, the last time we did this, we talked about the vertex form. All of these actually are not going to be in vertex form. They're going to be in standard form. Y equals, where is it? We'll write it in this one. They're all in standard form of y equals ax squared plus bx plus c. So then to find your axis of symmetry, remember that's just the equation x equals negative b divided by 2a. And then to find your y value for your vertex, you'll plug in the value you got for x back into your equation and solve for y. Okay. So starting this. Alright, first things first. Remember, we always want to label our A, B's, and C's. You can label it above your numbers. You can label it off to the side. And I know we haven't used C yet, but we will soon. And just making sure y'all guys are comfortable with labeling C and which one C is important too. So your A is 1, your B is positive 4, and your C is a negative 5. So then to find your axis of symmetry, that's going to be x, which is equal to negative b, so negative 4, divided by 2 times a, which gives you negative 4 divided by 2, which gives you a negative 2. So then plugging this into your calculator, which I did not bring mine, and I did not bring my phone either. Okay. You get y equals negative 2 squared plus 4 times a negative 2 minus 5. I'll just do this by hand, that's fine. So you square the negative 2, and remember to put that in parentheses if you put it in the calculator, or you can remember anything squared is that number times itself. So it'd be negative 2 times negative 2, a negative times a negative is a positive, and 2 times 2 is 4. And then you need to do the multiplication right here. So 4 times a negative 2 is actually a negative 8, because a positive times a negative is a negative, and 2 times 4 is 8. And then just bring down the negative 5. And then remember, when you get to addition and subtraction, you do it from left to right. So you would do 4 minus 8 first, which would give you a negative 8, minus 5, which would give you a negative 9. So then your vertex is at -2, -9. And then the next thing we'll do is we'll actually pull out that 1, 2, 3, 4, 5, 6, 7. Okay. Oh, should have drawn these a little bit wider. I don't know why I slimmed it down going down. Okay. Either way. Alright, placing your vertex in the very center of this, -2, -9. 1, 2, 3, and I wrote it in the wrong spots. Yeah, there we go. So there should be 3 blanks. Yeah. Alright, so to fill out the x values, you look at the numbers that are to the left of -2, which are actually the numbers less than -2. So to the left of -2 on a number line, you would find -3, -4, and -5. To the right of -2 on a number line, or the numbers increasing, so bigger than -2, would be -1, 0, and 1. Alright, and you can do these each by hand by replacing this -2 with -5 inside of them. You can do it by your calculator. If you had written this and just hit enter, you could rewrite this each time, but instead of the -2's inside, you're going to place each x value in there. Either one of the two works. You're actually going to get 0, -5, -8, -9, -8, -5, 0. If you want to double check that, that's great, because I don't remember if you tuned into like 2 videos ago where I completely did a really big mathematical error, and I realized it like 5 minutes later. Normally my students call me out on it in the middle of the lecture, but online school does not allow them to do that. There we go. I hope y'all like cats. Alright, and since -9 is the biggest one, I'm going to go out 9 ways. 9 ways. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you do it on the homework sheet that I gave you guys, it goes out to 10. Okay, so graphing that, starting off with the leftmost one, -5, 0. 1, 2, 3, 4, 5, 0. -4, -5. And then -3, -8, 5, 6, 7, 8. -2, -9. -1, -8. 0, -5, and 1, 0. Alright, and connecting those dots into a smooth parabola. As smooth as you can get it. This isn't my best work, but it's okay. Now, if you notice, whether you noticed it when you were plotting or you noticed it later on as you were graphing it, but right here at -5, 0 and at 1, 0, those are your 2 quadratic roots. You can also see them in your table when you put in -5, when you put in your x value and it spits back out a 0, that's one of your roots. That is one of your roots. You can see it in your graph when you put your things. If you get back a 0, that's your root. When you're graphing it, if you graph it and put your dot on the x-axis, guess what? That's a root. If it takes you after you graph and you can see, oh, it crosses at this spot right here, that's your root. And remember, Salem, move your cute little paw. Every single time you touch his paw, he wants to jump you. So, remember 2 solutions, because you have 2 circles, 2 solutions, means you have to write it as x equals, whoop, your open brackets, and it'll be your first x value of -5, comma your second x value of 1. So we only want the x values, we don't want the y values, because we know the y values are 0. And that's your answer. Alright, now doing one with one solution, and I'm obviously already telling you what to expect when you do this. Y equals x squared minus 2x plus 1. Alright, again, my first thing to do is to label my A, my B, and my C. I just had a venti coffee from Starbucks with an extra shot, so I'm kind of hyped up on caffeine. Alright, so your A is 1. Your B is going to be -2. And your C is going to be 1. Okay, from here we need to find our axis of symmetry. So our axis of symmetry, remember, it is x equals -b divided by 2a. Now, if your b is negative, you still have to write your negative number. You cannot just drop that b just because your b is negative. That does not mean if it's positive, turn it negative, and if it's negative, leave it alone. No, negative b means that when you plug it in, you're going to change the sign of b, so that sign changes the sign. If you originally had a b that's a positive, when you put it into the axis of symmetry equation, it's going to turn it to negative. If you had a negative b originally, when you put it into the axis of symmetry equation, it's going to give you a positive b. Because remember, this is a -1 times a -2. That's going to give you a positive number. So then you're going to have 2 divided by 2, and that's just 1. And then placing this back into your y values. So y equals 1 squared minus 2 times 1 plus 1. 1 times anything is itself, is what you multiplied it by, so 1 times 1 is just going to give you 1. -2 times a 1, that's just going to give you back -2, and then bring down the plus 1. So 1 minus 2 is giving you a -1 plus 1, which gives you a 0. So your vertex is at 1, 0. And if you listened to me earlier and I told you if your vertex is 0, you're going to know automatically you're only going to have one solution on this. So, and if not, we can 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Okay. Again, placing your vertex in the very center. It should be in the 4th spot. 1, 0. The number's immediately to the left, so if you had 1, then you would, if you jump back a spot, you'd get 0. If you jump back another one, -1, -2. If you jump to the right, you get 2, 3, and 4. Now then, you place each value of x in to this equation. So where you have 1, if you have your calculator, you just place each value of x in for the 1. So instead of 1, you put in -2 in both spots, then -1, then 0, then 2, then 3, then 4, and record what you get. You should get 9, 4, 1, 1, 4, 9, with 0 being in the middle, because we already found that. Alright. And then graphing this. Again, I'm going to go out to 9. If you have graphing paper that's already marked, that's great. If you don't, then you can just make your own graph. It's fine. Alright. So then starting with -2, +9. And I know I went all the way up to 9, so I can make this the very top dot. And then -1, +4. And then 0, 1. And then 1, 0. And then 2, 1. And then 3, 4. And then 4, 9. You can tell my dots are a little bit off, but it's okay. And then connect those into as smooth of a parabola as you can. Alright, and then right here you can see, if you right here, that 1, 0, your vertex is your only solution. So I said earlier that if, when you're finding your vertex and it gives you back, you plug in your axis of symmetry that you got, and it comes back with 0 as your y value, then you automatically should know that that's one solution, and that's going to be your vertex, because your graph is going to go up to your vertex and then touch the y-axis and then touch the x-axis and then run away. So, and then if you remember, one solution has just one number inside of there. So in this case, your answer would be x equals, well, you want the you want the x value, so you want that 1. Bam. Alright, one more, and then we'll talk about the discriminant. Salem has finally moved to lounge in front of the window because I have the curtain open and he likes the sun. Alright, number 3. So this one is y equals -x squared plus 2x minus 3. Alright. Finding my A, my B, my C. So if you have a negative at the beginning, that's a -1. That means your A is -1. This is a +2 as a B and a -3 as a C. So then finding your axis of symmetry, you go x equals -b divided by 2 times A. And if it's -1, make sure you put that negative in there when you solve. This is going to give you a -2 divided by a -2, which gives you a +1. So then plugging this back in, y equals -1 squared plus 2 times 1 minus 3. The reason I left the negative outside is because it's squaring the x value and then multiplying it against -1. If it wanted to square a negative x value, then it would have put the negative x in parentheses with the square outside of it. So plugging this perfectly into your calculator, or by doing it by steps, so this would be 1 squared is +1 times a -1 would give you a -1. 2 times 1 is 2, and then bring down the -3. Okay, and then -1 plus 2 is going to give you a +1. It's going to give you a +1 minus 3 gives you a -2. So then your vertex is at 1, -2. Okay, placing the 1, -2 in the center. To the left we have 0, -1, -2, 2, 3, 4. Alright, and then remember, place each value of x into your equation. Place each of these numbers into here for x and then solve it. You should actually get back -11, -6, -3, -2, -3, -6, and -11 back. Alright, so remember I said that the homework was only going to happen, so if it goes out to 11, and if you put in an x value and it gives you back a y value that's not on your graph, and you're working with a graph and it doesn't go out that far, you don't have to plot it. It's not required. You plot the ones that you can. If you're drawing your own graph and you want to go out to an 11 because you want it on there, then go ahead, go for it. Okay, then graphing these. Oof, this is not my best graph. 2, 3, 4, 7, 8, 9, 10. I'm only going to go up to 10. Alright, continuing on with this. Where did I put the blue marker? Oh, there it is. Sorry, I talked to myself a lot. Alright, since I only drew these up to 10, I won't be able to graph -2 and 4, but I can start with -1, 6. So I'd go back 1 of 6. 1, 2, 3, 4, 5, 6, and then 0. Did I do this one? Oh, I went up 6. I'm supposed to go down 6. 3, 4, 5, 6. There we go. And then 0, -3. And then 1, -2. And then 2, -3. And then 3, -6. Please ignore that dot. That wasn't supposed to go there. It went up 6 when it totally negative told me to go down 6. Alright, either way, connecting your dots, making it into as pretty of a parabola as you can achieve. Pew, pew, bam. Now, if you notice, this parabola actually never intersects or touches the x-axis because it says, gets close and says, yeah, right, you thought, and turns back around. So remember that you can write this as x equals the empty set or just no solution. Either of the two are acceptable. Alright, last thing to talk about is the discriminant. So the definition to the discriminant it's used to determine the number of solutions. And the formula? For this is actually that D, which stands for discriminant, is equal to b squared minus 4ac. And bam, that c finally came in handy. So this just means you square b and then you subtract 4 times your a value times your c value. This 4 is going to always be there. It doesn't just magically disappear. Now, some things to note about this. I'm going to read it big for you. I'm a very colorful. I like to do my notes colorfully and try to keep up with it. Alright. So, if your D is greater than 0, which just means if your D is a positive value, then there are 2 solutions. So this doesn't tell you what the solutions are. This just tells you how many solutions. So if you want to find your discriminant first on all of these, and then go and solve them and find out what they are, you can already go in there knowing. Okay, but if your D, if you calculate this and you come out with 0, then there are 1 solutions. Okay, then there is 1 solution. On the other hand, if your D comes out to be less than 0, so it's a negative number, then there are 0 solutions. So the way that this is set up in your homework is it has, it gives you an equation, and then you're supposed to use a discriminant to figure out whether it has 2, 1, or 0 solutions, and it'll have them right now with a little box, and you just need to check one of them. Oh, by the way, these are just little marks to say like this. Those does not mean negative. Probably should. Alright. Now then, for some examples. Number 10. Y equals 2x squared minus 4x minus 3. Alright, since all of our a values and our graphing ones only had 1 or negative 1, I'm actually going to use ones with a values that actually have a number but other than 1 in front of them. So in this case, I'm going to use 2x squared. Alright, so setting this up, I'd still recommend you determine your a is 2, your b is negative 4, and your c is negative 3. Alright, so then to find this, you're going to substitute each value of the letter for that letter in here. So if b, you have b in this first one, but you know b is negative 4, then substitute negative 4 in for b. And what that means is you're going to replace b with negative 4. So you're going to have negative 4 squared. Minus 4, that doesn't get replaced. And then you have a next, so then you're going to replace a with 2. And then you have c at the very end, which we know is negative 3, so then you're going to replace c with negative 3. And bam. And then you can put this in just like this, negative 4 squared. Make sure you put it in parentheses, minus 4 times 2 times negative 3. Enter. That's totally a solution. You can do that. Doing this by hand, negative 4 times negative 4 quantity squared, we're going to give you a positive 16. Doing negative 4 times 2 will give you a negative 8. Still multiplying it by that negative 3, so that's going to give you 16. Negative 8 times a negative 3 is going to give you a positive 24. So then this gives you a value of 40. Note that 40 is greater than 0. So you replace each of these d values with the number that you get. So 40 is greater than 0. So you would check the box that says 2 solutions. Bim! Yeah, I want that one. Positive numbers give you 2 solutions. Alright. Number 11. Y equals 4x squared minus 12x plus 9. I don't know if you have realized, but I have a tendency to jump between using my 2 like this and writing my 2 like that. If I write a z, my 2's kind of sometimes look like z's, but I always throw a line in my z. So, alright, so a, b, c. A is 4, b is negative 12, and c is 9. So then again, writing the discriminant equation, except replacing each a, b, and c for its correct values, you would get that discriminant equals b squared, whether it's positive or negative, you have to square the whole number, minus 4 times a, which is 4, times c, which is 9. Negative 12 squared, that's going to give you a positive 144. Negative 4 times a positive 4 gives you 16. Negative 16. And then negative 16 times 9 actually gives you back 144, which this is 0. And obviously if you get back 0, then 0 equals 0. And if your d equals 0, then you're going to go to the box that says 1 solution and mark that one off. So it's actually like a box that says your answer choices look like 2 solutions, 1 solution, 0 solutions. But it's really tedious to write that all over again, so I'll just write the answer. So this one should only have the 1 solution box marked. Alright. And if you haven't guessed it already, this next one should give you no solutions. I like to do one of each example so y'all can see each one. So this is y equals negative 3x squared plus 5x minus 8 Alright, so your A value, your B value, and your C value. Your A value is -3. So then writing your discriminant equation again, except putting in the correct values of A, B, and C, you'll get B squared, which is 5 squared, minus 4 times A, which is -3, times C, which is -8. Okay, 5 squared is going to give you back 25. -4 times a -3 gives you back a positive 12 times 8. Okay, well then, times a -8. Don't drop that negative. Okay, and then 12 times a -8 is actually going to give you a -96. So then 25 minus 96 is going to give you back a -71. Note that -71 is less than 0. It is a negative number. Negative numbers have no solutions. So then you go to that bottom little box that says 0 solutions. And you say, yep, that's it. That's the one I want. I want the one with no solutions. Now again, the discriminant does not tell you what the solutions are. To find out what your solutions are, you'd have to go back and find your table of values and figure out, like, find your vertex, fill out your table of values, and figure out which x values give you back 0, or where does it cross the x-axis. The discriminant only tells you to like, if we did the discriminant on this one first, and then we went to go graph it because we wanted to know what those were, then you would know you need to look out for 2 solutions. So 2 x values are going to give you back 0. So it kind of gives you a heads up of how many to look for.